Next on the agenda, we have the Lustre contribution model. This will be presented by Nathan Rutman. Nathan Rutman, in addition to being a really great guy, has been working on software and embedded systems for 18 years. Beginning work on Lustre in 2004, he's held positions with Cluster File Systems, to Sun, to Oracle, through his current position with Xyratex. Currently, Nathan is a senior software architect at Xyratex, responsible for file system feature designs and systems integration. Thanks.
Thanks, Steve. Hey, you know what? I actually had an idea. Is it possible to put these presentations online somewhere we can all look at?
The plan is to put them online. Rather than put them online right now, I wanted to make sure that people were paying attention to you rather than their laptops.
Okay. For those that can't see well, it's kind of nice, but anyhow, okay. So the Lustre contribution model, and in particular what Xyratex does in terms of Lustre coding. So what am I going to talk about is why a unified tree is important, why a non-unified tree is important, or why we need custom distributions as well. A little bit about how Xyratex does code development and integration, a little bit about testing, and then reunification, what I'm calling kind of the reintegration with the kind of the canonical Lustre tree. So why do we need a single Lustre tree? It's somewhat obvious. So there are lots of different environments that run Lustre. They experience lots of different bugs. We all want to benefit from the shared contributions of bug fixes and features. Different institutions have different priorities on both these bugs and on features that they want. So because Lustre is open source, we can all work on what we want, contribute it back to a single tree, and we all get to use all these fine new features. The third point is that if everyone's working from the same tree, we get a well-tested tree. So if everyone has different branches, everyone's testing their own branches, presumably, then there's less testing on a unified tree. Why do we need a custom Lustre distribution? Well, interestingly, the first 2 points are the same. Or maybe not so interestingly. We have different bugs and different environments, and everyone's interested in their own bugs over pretty much everyone else's. We have different priorities of features as well. And so we want our features added first, and we want our bugs fixed first. Also, some of the features that we want may or may not be of interest to the rest of the Lustre community. So there's somewhat of a question about what is, kind of core Lustre and what's not. Is hardware CRC support important for people that don't have, CPUs that are capable of dealing with it? No. Similarly, people that run hardware RAIDs don't care about MD RAID zero copy patches. So there's a bit of a question there about what exactly belongs inside of Lustre. So with our own distribution, we can kind of make sure it all goes in kind of on our scale. Another point there is that the canonical tree, as hosted by Intel, has what to us is an external gatekeeper. So there's someone that tells us whether our code can land on the canonical tree or not. And for our development, we obviously can't have that when we're deploying code to our customers and updating their software in the field. So there's I put a couple of bullet points there. So for instance, one of the patches we've worked on is a short I/O patch that provides some minor amount of performance enhancement for some less than minor amount of code. So the question is, well, is it worth it to the source tree to add that feature? There's some risk involved. There's some benefit. Maybe the weighing of that benefit is ultimately up to the gatekeeper. So we have to be able to make our own decisions there. Another reason we need our own custom Lustre distribution is for stability. We need a system that is not taking any and all patches that may very well improve the Lustre tree and may very well add features, but any feature landing involves risk. And so we have to be able to make our own evaluation of risk, not only of our own features, but of upstream features as well. And then finally, we have to have our own distribution in order to have our speed of turnaround. So we need to be able to react to specific situations in a rapid manner. So during the Blue Waters deployment, we had people around the world working 24/7 for 2 weeks straight, getting metadata issues sorted out, and we have to have our own tree in order to update and release those to our customers. So a little bit more on priorities and how different organizations prioritize different items. So firstly, we all, the Lustre groups here have different customers, and our customers have their own different bugs. So we each have to prioritize them somehow. We have sales support. Sales may indicate that a customer wants a new particular feature, so we may prioritize that feature for potentially gaining some gaining some sales. Our own future product plans are dependent on our own forecast of what. Oh, that got bright. Forecast of what we need to provide to future product development. And then we have a long list of stuff that we're already working on, our feature backlog, that we have to kind of fold into this big kind of prioritization schema. Some of the ways, well, one of the ways that we kind of try to address these different prioritizations is by dividing our support staff into, our Lustre engineers into two kind of virtual groups. One is a group that works on sustaining kind of bug fixing stuff, and one that just does new features, so that we can kind of keep moving those forward at the same time. We're working on all of the issues that need to be addressed kind of right away. So now a little about how Xyratex does code development. So much as Sun and, well, CFS, Sun, Oracle, and probably Intel as well does, we use Jira to track tickets now. Well, Sun doesn't, they still use Bugzilla, I suppose, but a ticket tracker, tickets come in from internal or external sources. Those have to be triaged in order to prioritize how important they are and when we need to work on them. We add in our roadmap planning into there to help with the feature prioritization, where we want Lustre to go, where we want our product to go, to help choose what we're working on. And then how do we work on code? So we use the TSP, which has been used since CFS days. The TSP is the team software process where code is developed. Well, where first designs are written down. There's a high-level design, a detailed-level design. There's coding. Each of these phases has a distinct review phase, and then code is inspected by reviewers, two reviewers generally, and goes through automated test cycle. And after that approval, kind of approves along the way, we have our own gatekeeper that decides when a feature is ready to land in a maintenance or release branch, to ensure, again, that he's the ultimate authority in whether a feature is ready to be released and included in our release. The review process at Xyratex is fairly well automated, so we submit our patches up to Garrett. Garrett immediately starts off a Jenkins job to build any patches that are up for review. That Jenkins job then starts an automated testing job with a tool called Xperior that was developed by Roman, who's sitting somewhere around here. That is an automated testing tool that can test, well, Lustre, and it sits at a kind of a higher level than the acceptance small style testing. The results from Jenkins are posted back to Garrett, so the reviewers can kind of immediately see whether the build worked and all of that. And then the tickets themselves, the patches as submitted through Git, get tagged by these little review by. You can't really see that on there, but they say reviewed by. Those little comments get added automatically to the Git comments, so we can kind of track all of this stuff, including who's approved, whether the test passed, all of that stuff gets included in the Git comments. All right. A little bit more about Xperior. I actually talked about this at Lab last year, but I'll do a minor update. So Xperior is started by a Jenkins automated build system, or automated, well, Jenkins is an automation system. We have kind of YAML style configurations, test descriptions, and results files, so that they can all be stored in either stored as a machine-readable and human-readable form. And we open sourced this last year, actually, so in case anyone wants to use it, you're welcome to it. The idea here behind Xperior is actually that it can be used for broader testing than just the acceptance small stuff that's kind of been being done with Lustre today. Xperior was designed with kind of a plug-in architecture, so there's the code coverage tool that we posted some various code coverage results and static verification tool results. We posted some of these results to OpenSFS website, but they're all generated from Xperior. So finally, how do we reconcile our individual code tree with the upstream canonical code tree? So the first thing we do is we cherry pick bug fixes and features from the upstream tree that we like. So right now our baseline is Lustre 2.1, and obviously the canonical tree is all the way up to 2.4. There are plenty of nice features that are in those releases in between there. So things like wide striping, which was critical for our last deployment, for Blue Water's deployment, and imperative recovery are things that we like, and we backported to Lustre 2.1. We did not move forward because we did to 2.2, et cetera, because we had the experience and the testing depth of 2.1 that we felt that it was important to keep that stability as long as possible. So we're kind of on the model at this point of staying with the maintenance releases, including any bug fixes and features that we want and pulling them back. In the other direction, every bug fix that we make and every feature we develop is pushed back upstream. So we have a lot of code that's sitting in Jira tickets at the Intel Jira, and I've been encouraging our developers to include back references to the original, our internal Jira system, so that we can kind of easily add more information as required. So our engineers then spend the effort to attach the patches, address inspection requests and questions, update the code, and get these patches landed, even though they're already in our releases. So this is basically purely to keep the upstream code as stable and as featureful as possible. Sometimes there are conflicts between what the canonical code tree has and what we have, and the conflicts may come from priorities of what they want to land versus what we want to have landed. Sometimes there's actual code conflicts. That's just, part of doing business. That doesn't bother me at all. There will be conflicts. We work through them, and eventually, the feature will land. And to avoid the problem of long delays, we also publish our entire tree up at GitHub. So you can pull that down along with Livermore and NASA and other people put their trees up as well. That's it, short and sweet.
Cool. Questions?
No, I'll take a bow. Thank you.
Nathan Rutman.